Hello and welcome to Math Matters. I'm Ms. Granados and today we're going to continue learning about probability. By the end of this lesson, you should be able to use a fraction to accurately describe the probability of an event. You will need some paper and something to write with. Grab your supplies and then come right back. Remember this problem from yesterday? In yesterday's lesson, I asked you to create a tree diagram and a list of all the possible combinations that Ryan could select. Go ahead and pull that paper out and compare what you wrote with the next slide. Here's my tree diagram for Ryan's snack options. I used my tree diagram to help me create my list. In order to make sure I included all the combinations, I started with the milk combinations, listing each one by following the branches or lines. Then I repeated them with the juice combinations. Altogether, Ryan has 12 different combinations he can choose from. Let's move on to our number sense routine. Which one doesn't belong? Take a look at these 4 different spinners. Is there one that doesn't belong? Could there be another one that doesn't belong? What's a reason each of the spinners might not belong? Maybe you thought this spinner doesn't belong because there's too much orange. In fact, more than half the circle is orange. None of the other spinners gives that much space to any one color. The top right one might not belong because it's the only one with 3 colors. The bottom one doesn't belong because the blue section doesn't represent 1/4 like it does in all the other circles. And the top left spinner doesn't belong because it's the only one that is divided into 4 equal parts. Let's take a closer look at this spinner. We just said that the circle was divided up into 4 equal parts. This means that each section represents 1 out of the 4 equal sections, or 1/4 of the circle. There are 4 different colors, so each color represents 1/4 of the spinner. What is the probability of spinning the spinner once and landing on orange? Well, probability measures how likely an event will occur. We can use the terms impossible, unlikely, likely, certain, and equally likely to describe the likelihood or probability of an event. We see that 1/4 is orange and 3/4 of the spinner are not orange. So we can say that the likelihood of landing on orange is unlikely. Probability can also be expressed as a fraction. The numerator is the number of favorable outcomes, and the denominator is the total number of possible outcomes. In the question just posed, what is the probability of spinning the spinner once and landing on orange? The number of favorable outcomes would be the number of orange sections, which is 1. And the total number of possible outcomes would be the total number of sections, including the orange section. 1, 2, 3, 4. So in this example, the probability of landing on orange is 1/4, or 1 out of 4. So the probability of landing on orange is 1/4, or 1 out of 4. What's the probability of spinning the spinner once and landing on green? Well, yeah, it's also 1/4, because the green section is 1 out of 4 equal sections. What's the probability of spinning the spinner once and landing on blue? Yep, it's also 1/4. And what's the probability of spinning the spinner once and landing on purple? Yep, also 1/4. We can show probability on a number line as a fraction between 0 and 1. If we continue to divide this line into 4 equal parts, we can label this as 1/2 and this as 1/4. If an event has a probability of 0, we say that it is impossible that it will happen. For example, if today is Wednesday, it is impossible that tomorrow will be Sunday. If an event has a probability of 1, we say that it is certain that it will happen. In a similar example, if today is Wednesday, it is certain that tomorrow will be Thursday. If an event has a probability of 1/2, we say that it is equally likely that it will happen. So when we flip a coin, the probability of landing on heads is 1/2. What if an event has a probability of 1/4, like landing on one of the colors of the last spinner? We call anything that has a probability between 0 and 1/2 as unlikely. If an event has a probability greater than 1/2 but less than 1, we say that it is likely to happen. In other words, the probability of landing on any one of these colors is 1/4, and the likelihood is unlikely, since 1/4 is between 0 and 1/2. Now let's think about the probability of rolling a 6-sided die one time. There are 6 possible outcomes you could roll: 1, 2, 3, 4, 5, or 6. What is the probability that you roll a 3? Well, how many times does the number 3 appear in our list of possible outcomes? Just once. And how many total outcomes are possible? Yeah, there are 6 possible outcomes. So the probability of rolling a 3 is 1 out of 6, or 1/6. And we know that 1/6 is close to 0, so the likelihood of rolling a 3 is unlikely. What is the probability that you roll a number less than 7? Yeah, all 6 possible outcomes are less than 7. So the probability is 6 out of 6, or 1. It is certain that you will roll a number less than 7. What is the probability that you roll an odd number. Well, how many odd numbers are listed? Just 1, 3, and 5. So 3 possibilities out of the 6, or 1/2, means that it is equally likely that you will roll an odd number as you would not roll an odd number. Okay, now it's your turn. Get your pencil and paper and write down the fraction that represents the probability for the following events. We'll review the answers after you finish answering all 4 questions. Looking at this spinner, what is the probability of spinning a 2? What is the probability of spinning an even number? What is the probability of spinning a prime number? Remember, the number 1 is neither prime nor composite. And what is the probability of spinning a number less than 6? Okay, let's review the answers. The probability of spinning the number 2 on this spinner is 1 out of 5, because the number 2 appears 1 time out of 5 possible numbers on the spinner. The probability of spinning an even number is 2/5, because only 2 and 4 are even numbers. The probability of spinning a prime number is 3/5, because the numbers 2, 3, and 5 are all prime numbers. 1 is neither prime nor composite, and 4 is composite. And the probability of spinning a number below 6 is 5 out of 5, or 1, since all the possible outcomes are less than 6. How did you do? What about this problem? Chrissy has these towels in a bag: 4 white towels, 2 yellow towels, 3 blue towels. What is the probability that the first towel chosen at random from the bag will be white? Okay, what do we know? We know that Chrissy has towels, right? 4 white, 2 yellow, and 3 blue. So how many towels is that in all? That's right, she has 9 total towels. But what is the question asking? What is the probability that the first towel chosen at random, meaning that Chrissy's not going to look at the colors before picking one out of her bag, will be white? So what we're really interested in is how many towels are white. Yeah, there are 4 white towels. And the total was 9 towels in the bag. So the probability that she will select a white towel is 4 out of 9, or 4/9. Let's try this problem. A picnic cooler holds these bottles: 10 bottles of water, 8 bottles of milk, and 6 bottles of juice. If a bottle is pulled at random from the cooler, what is the probability that the bottle contains juice? What do we know? Well, we know that there are 10 bottles of water, 8 bottles of milk, and 6 bottles of juice. So we can figure out the total of all the bottles in the cooler. If we add up all the bottles, we know that the cooler has 24 bottles. What do we want to find out? We want to know what the probability is that the bottle will have juice. So, yeah, there are 6 bottles of juice in the cooler, and there are 24 bottles in all. So the probability that we'll pull out a juice bottle is 6 out of 24. We may need to simplify the fraction, so we can divide the fraction by 1, or 6/6, to find an equivalent fraction of 1/4. Trent used the spinner shown to play a board game. Each section of the spinner is the same size. What is the probability the arrow will land on a section labeled green on Trent's first spin? Okay, so how many sections are there in all? That's right, there are 10 sections on this spinner. Since the question is asking about the probability of landing on green, we need to count how many sections are labeled green. Here we see 2 green sections. So the probability of landing on green on this spinner is 2 out of 10, or 2/10. We can simplify that fraction by dividing by 1, or 2 out of 2, to get 1/5. We did a lot of work with probability in different scenarios during this lesson. This was the learning target for today's lesson. How do you feel about your ability to use a fraction to describe the probability of an event? Were there some times that you felt strong and other times that you felt maybe you needed more time or more help? If that's the case, write it down so that you can talk to your teacher about it. This week we've been learning about probability. Tomorrow we're going to learn about the fundamental counting principle to help us figure out the total number of combinations or outcomes possible. Make sure to come back to learn more tomorrow. For Math Matters, I'm Miss Granados, and thanks for watching. Have a mathematical day and keep on counting.